Hey, it's Jay. I'm here in the exercise room to talk about different types of muscle contractions. Humans need to move to stay alive, and muscles are responsible for movement. I'm not going to make it very far if I can't breathe or pump blood. Muscles are the motors that are responsible for movement. They take the energy from food and convert it into force. Notice I said force and not motion. I can contract my muscle, like my biceps there, but there's no movement. When I contract a muscle and it doesn't move, it's called an isometric muscle contraction. Now, we need to define muscle contraction. Contraction just means a muscle is generating force. The word contraction doesn't tell us anything about muscle length. A contracting muscle could be getting shorter, longer, or not moving. There are actually three different types of muscle contraction. I'm going to be using movement of the elbow to talk about all three. Now, before we get started, we need to know the definition of elbow flexion and extension. Elbow flexion is when I move my wrist closer to the shoulder. Elbow extension is when I move my wrist further away from my shoulder. Primary muscles responsible for elbow flexion are the brachialis and biceps brachii. They're attached to bones so that when the muscles contract and shorten, they're going to flex my elbow. There are three different types of muscle contractions: concentric, isometric, and eccentric. I'm going to pull out the bigger dumbbell to illustrate these. In a concentric contraction, the muscle contracts and the muscle shortens. So my elbow flexors, the brachialis and biceps brachii, they contract and shorten. In an isometric contraction, the muscles contract but don't change length. And in an eccentric contraction, the muscles contract but they lengthen. In this case, the elbow flexors are contracting but they're getting longer. Now, in a concentric contraction where the muscle wants to shorten, this is what the muscle wants to do. At the molecular level, the myosin molecules are exerting force to shorten the sarcomeres, and they're successful. In an isometric contraction, the cross bridges are still cycling, but the sarcomeres are not changing length. Every time the myosin molecules take a step to shorten the molecule, the opposing force lengthens the sarcomere the same amount. There's enough play in the sarcomere for that to happen. Now, in an eccentric contraction, where the elbow flexors are contracting, but they're getting longer, the cross bridges are also cycling. The force exerted by the cross bridges to shorten the sarcomere is offset by the opposing force that's lengthening the muscle. So in an eccentric contraction, the muscle isn't causing the movement, but resisting the movement. In this case, the movement of the dumbbell is caused by gravity, and the elbow flexors are just resisting that force. So there's an important principle at work here. Muscles can only exert force to shorten. The myosin motors are always trying to shorten the sarcomere. My elbow flexors can only try to flex the elbow. When we expose our muscles to repeated eccentric contractions, we're moving the muscle in the direction it doesn't want to move. This can result in microtrauma in the muscle and inflammation. If you've ever gone hiking and walked down a mountain, you've exposed your leg muscles to repeated eccentric contraction as you've slowed the weight of your body going down the mountain. You may have been sore the next day. That's called delayed onset muscle soreness, and it's due to repeated eccentric contractions that have resulted in the microtrauma and inflammation. It takes a few hours or even a day or two to develop, but it resolves over time. Now, after you've been doing eccentric contractions for a while, you'll no longer get the delayed onset muscle soreness. Your body will adapt. If I want to extend my elbow, I have to use a different muscle group, ones with attachments, so that when the muscle shortens, it extends the elbow. In this case, it would be the triceps, which has an insertion on the posterior portion of the ulna. Muscles that perform opposite actions are called opposing muscle groups. Typically, when one muscle contracts, the opposing muscle group relaxes. This means that when we concentrically contract a muscle, we're reducing the load created by the opposing muscle group. Okay, so muscles are responsible for movement in our bodies. The muscles can cause the movement by contracting concentrically, or they can oppose movement created by an external load. That would be either isometric contraction or eccentric contraction.